compartments of the leg. Now we will start with the next part, that is the sole of the foot. So as a rule, before we going into the dissection and the introduction of the structures in the sole of the foot, we should know what are the arrangement of the various bones in the sole of the foot, or what is called the plantar surface of the foot. So this is the plantar surface of foot, that is also called the sole of the foot. The various bones which are arranged in the sole of the foot, they are the tarsal bones. So what are their mutual relationship, or when we see all tarsal bones from the plantar side surface, what are and how they are looking. So first is the bone of the heel, that is the calcaneum. Plantar surface of the calcaneum, it bears in its posterior part a tuberosity that is called the calcaneal tuberosity. It has a large medial part and a small lateral part, and in between there is a notch. This is called the tibial tuberosity. Anterior to this, there lies a tubercle that is called the calcaneal tubercle. So this is the calcaneal tuberosity and this is the calcaneal tubercle. And this is the shelf-like projection medially, that is called the sustentaculum tali. It is the plantar surface of the what is called the calcaneum. The lateral part of the calcaneum, anteriorly, here is the articulation of a bone, tarsal bone, that is called the cuboid bone. So cuboid bone is there. We are touching the plantar surface of the cuboid bone, and in this cuboid plantar surface, there is an obliquely running groove is there on the plantar surface. This is the oblique groove on the cuboid bone. Then medially, there is the head of the talus bone, which anteriorly articulates with the board-shaped bone, that is the navicular. And navicular is also having on its plantar surface a obliquely running groove. Then anteriorly, this navicular bone has got three cuneiform bones attached to it: medial, intermediate, and this is the lateral cuneiform bone. The medial cuneiform bone articulates anteriorly with the first metatarsal, with the broad base, and this is the head of the metatarsal. Similarly, the intermediate cuneiform, it articulates with the second metatarsal, and lateral with the third metatarsal, and cuboid anteriorly, it articulates with the fourth and the fifth metatarsal. The fifth metatarsal, as we know, on its lateral side has got a tuberosity, that is called the tuberosity of the fifth metatarsal. Then the great toe is having only two phalanges, the proximal and the distal. While all the other fingers, they have got the three phalanges, the proximal, the middle, and the distal phalanx. So we are looking the inferior or the plantar surface of the tarsal bones, how they are present. Now these tarsal bones, they are having the fibrous capsule of their intertarsal joints. So they are all together. Along with there are certain ligaments also. One ligament from the calcaneum goes to the navicular bone. This ligament runs over the head of the talus. This is called the spring ligament. This is the spring ligament. Or it is also called calcaneo-navicular ligament. Calcaneo-navicular ligament. The superior surface of this ligament supports the head of the talus and prevent it to touch the ground. So this is the spring ligament. Then from the calcaneal tubercle, a ligament goes anteriorly and it converts the groove for the Peroneus Longus into a tunnel by its attachment, and this ligament is called the short plantar ligament. This is the short plantar ligament. That is also called the plantar calcaneo cuboid ligament. And over it, there is another ligament which is attached to the calcaneal tuberosity, and it runs over the short plantar ligament, and anteriorly it is attached to the bases of the third, fourth and fifth metatarsal bones. So this ligament is longer, so it is called the long plantar ligament. It is a long plantar ligament. So this ligament maintains the lateral longitudinal arc of the foot. Then heads of the metatarsals, they are also joined together by a transverse ligament, which is called the transverse metatarsal ligament. Transverse. Metatarsal ligament. So this ligament maintains the transverse arch of the foot. Transverse arch of it. So this is how the ligaments, they are present over the plantar surface of the various tarsal bones. So they are also very helpful. Now the sole of the foot is divided into 4 layers, which contains the muscles. They are the intrinsic muscles. So these muscles, they take origin from the tarsal bone and they are inserted into the tarsal bones of the foot. So we will take one by one all the 4 layers of the foot, sole of the foot. But before we going, so whenever we do the dissection of the sole of the foot, first we remove the skin of the sole. The skin of the sole, or what is called the dermis, is very thick. Why? Because it is a weight bearing part. Whenever we stand, whole of the weight falls on the sole of the foot. So in order to prevent the friction between the ground and the skin of the sole, so the dermis becomes much thicker. Plus, beside the thickened part of the superficial fascia, the second layer is also, which contains the fat, is also very thick. And this thick pad of the fat over the certain areas, they are much more, which are the bony points which touches the ground of the foot. For example, it is very much thick over the heel, plus over the heads of the metatarsal bones and over the tips of the digits, because these are the areas or the bones which touches the ground, and there are chances that the skin may be torn due to friction between the hard ground. Another maneuver to protect the muscles and the nerves and arteries and the veins of the sole of the foot, after when we remove the skin of the foot, sole of the foot, by cutting in the middle and reflecting it, we got a layer that is called the plantar aponeurosis. Plantar aponeurosis. So plantar aponeurosis is a condensation of the deep fascia of the sole of the foot. It is attached posterior to the calcaneal tuberosity, and anteriorly this plantar aponeurosis runs in a forward direction to every digit. It goes and divided into 10 slips, 2 for each base of the fingers or the digits. So this is the plantar aponeurosis. So it is a protective and protects the deeper layers of the muscles and the artery, veins and nerves of the sole of the foot. So it is very rough and tough and weight bearing also. From its medial side, it is continuous with the dorsum of the foot, the deep fascia over the dorsum of foot, laterally as well as the medially. So lateral and medial border of the plantar aponeurosis, they are continuous on the dorsum of the foot with the deep fascia covering the dorsum. Plus, below this medial part, there is a septum which goes deep to the deep surface of the plantar aponeurosis. This is called the medial intramuscular septum, and it gets attached to the shaft of the first metatarsal. Similarly, there is a lateral intramuscular septum is present laterally from the deep surface of the plantar aponeurosis, just before the lateral border continues with the dorsum of the foot. A septum goes and gets attached to the shaft of the fifth metatarsal. And because of these two, medial and the lateral intramuscular septa, the compartment of the sole of the foot is divided into medial, intermediate and lateral compartments. Medial, intermediate and the lateral compartment, which contains muscles, artery, veins and various nerves. So that is the plantar aponeurosis. Now we will take we cut this plantar aponeurosis in the dissection part from the calcaneal tuberosity, and we lift it upward to expose the first layer of the sole of the foot. So when we cut it from here, then we cut from the attachment to the first metatarsal, then we cut along its attachment to the fifth metatarsal, then we cut along where it continues with the deep fascia of the sole of the foot. dorsum of the foot. So we cut from here also. After cutting these, now it is free. No doubt, its superficial surface may give rise to some muscle of the first layer, but we remove it and reflect it upward so that we can expose the layers of the sole of it. So in this way we lift the plantar fasciitis by cutting from the incision from back side and making it upward so as to expose these layers of it. Anteriorly, these parts of the 10 processes of the plantar fasciitis, they get continuous with the dorsal as well as the flexor digital expansions of the plantar surface of the fingers. The flexor expansion is attached to the various fibrous capsule of the joints of the interphalangeal and the metatarsophalangeal joints, plus the ligaments attached to these joints, small joints of the finger. So that is how they are fused together to form the flexor sheaths along the tendons which are entering into the fingers. So when we remove this and reflect this plantar fasciitis, immediately below we see the first layer of the muscles of the sole of the foot. First metatarsal, this is the uniforms, medial, intermediate and lateral uniforms, and the metatarsal bones. The third is the fourth, and the fifth will be tuberosity. So this is the exposure, what is called the first layer of the sole. The first layer of the sole has got every layer has got 3 muscles. To remember, the first layer has got the muscle in this layer. The number 1 muscle is called the Abductor Halosis. Second is the Flexor, the Digitorum brevis muscle. Third muscle is Abductor digiti minima. These are the 3 muscles we see here in the first layer after removal of the plantar fasciitis deep to it. So Abductor halosis. So this Abductor halosis muscle, as the name suggests, will bring about the abduction. So for the abduction and the adduction movements of the fingers and the digit of the sole, we take the first finger as the standard. Any digit or the great toe, if it is moving towards this first finger, is called the adduction. And if it is going away from the first finger, this is called the abduction movement. Whether great toe or other fingers. So this is how to remember. We take the first finger. However, in the upper limb, in the hand, we take the middle finger as the standard. And these 2 fingers and thumb, if we move like this is the adduction. Away from the middle finger, abduction. But in the lower limb, you have to remember not the middle finger, but we take the first finger as the guide for the adduction and the abduction. That is the only difference between the palm and the foot. So abductor halosis means, first word is telling that it will do the abduction. Halosis means great toe. So when this great toe will move towards away from the first finger, so it is the action of the abductor. So abductor halosis muscle will take over from the sustentaculum tali, then from the flexor retinaculum, and the deep surface of the plantar fasciitis is the origin. And this muscle from this origin goes medially and is inserted over the base on the medial aspect of the proximal phalanx of the great toe. Proximal phalanx of the great toe, medial. So origin inserted, so whenever this muscle will contract, the proximal phalanx will go away from, and this is the abduction. Similarly, abductor digiti minimi. So this abductor digiti minimi muscle has to abduct the little finger. So this muscle will take origin from the cuboid bone, and it goes laterally and over the fifth metatarsal, and it is inserted over the base of the proximal phalanx. So it also brings the abduction movement of the little finger away from here to the abductor digiti minimi and abductor halosis. In between the two, there is a third muscle that is called the flexor digitorum brevis. So going to the name of the muscle, first word of this muscle is telling that it will do the flexion. Digitorum means its tendon will divide into 4 slips, one for each digit. And brevis means it is brief, so it won't insert on the terminal or the distal phalanx. So this is how we study it. So origin of this flexor digitorum brevis muscle is from the calcaneal tuberosity, and from here this muscle will go in the forward direction, and anteriorly this muscle will divide into 4 steps for every finger or the digit. And when it reaches the plantar surface of the finger, there are 3 phalanges: proximal, middle, and the distal phalanx of the fingers. All fingers having the same. So this slip will divide into 2 slips and inserted on the either side of the middle phalanx. Either side of the middle phalanx. So that is the insertion. So the fibers they decussate, they cross, and this slip is inserted on the either side of the middle phalanx is the insertion of the flexor digitorum brevis. So in every finger same thing is happening. So all are inserted on the, after crossing into the either side of the middle phalanx. So that is the fate of the flexor digitorum brevis. And what will be the action? So whenever this muscle will contract, all the fingers will move like this. So the movement is at the interphalangeal, proximal interphalangeal joint and the metatarsophalangeal joint. So this is how the fingers are. So this is called the plantar flexion of the fingers. So this happens when we walk. This plantar flexion will help in the gripping of the foot on the ground, and it stabilizes our standing as well as the walking posture. Now comes the nerve supply. As we have seen that the structure passing behind the medial malleolus, we have done it. Behind the medial malleolus, we have seen that 5 structures they pass, and out of these 5 structures, one is the posterior tibial artery, which goes into the sole of the foot, and behind this artery is the tibial nerve. It also goes into the sole of the foot under the flexor retinaculum, along with the 3 muscles. So before going to the sole of the foot, the tibial nerve will give the branches, that is the calcaneal branches, lateral calcaneal branches, accompanied by the lateral calcaneal branches of the arteries also. They pierce the flexor retinaculum and they supply the medial surface of the skin over the calcaneal. After that, this tibial nerve will go into the sole of the foot, and in relation to this tentaculum tali, the nerve appears between the flexor digitorum brevis and the abductor halosis here. And this tibial nerve will divide into 2 branches. A large medial branch and a small lateral branch, which goes deep to the muscle, into the medial plantar nerve and the lateral plantar nerve. This medial plantar nerve will supply the abductor halosis. Plus this also supplies the flexor digitorum brevis muscle. The lateral plantar artery goes laterally, and it will supply the abductor digiti minimi. Plus, the medial plantar nerve also have got these sensory branches, and it supplies medial 3.5 fingers skin, while the lateral plantar nerve will supply the lateral 1.5 skin of the fingers. So that is it. Arrangement you have to remember, medial 3.5 and lateral 1.5. That's how these innervate the skin of the sole of the foot along with the thumb, 1, 2, 3 and half of this finger. So this is the 3.5 supplied by the medial plantar nerve, and half of this finger and the little finger whole. 1.5 is the sensory nerve supply of the lateral plantar nerve. Then same is the artery. Posterior artery is also enters into the sole of the foot along with the nerve, and when it enters it along with the nerve, so this artery also divided into 2 branches. One is called the medial plantar artery, which runs on the medial border of the foot. It is a small branch and supplies the muscles on the medial aspect. The lateral plantar artery, it goes between the first and second layer, then deep to the flexor digitorum brevis muscle along with the lateral plantar nerve. This lateral plantar artery goes laterally and it goes up to the tuberosity of the fifth metatarsal along with the nerve, and it supplies the muscles on the lateral aspect and structures on the lateral part. So this is the fate of the tibial nerve and the posterior tibial artery in the sole of the foot. So this is the arrangement in the first layer of the foot. Then we do the second layer. In order to do the second layer, we cut the flexor digitorum brevis muscle. From here, the flexor digitorum brevis muscle is cut, and then it is also reflected like the plantar fasciitis upward. After that, we got the second layer. The muscles of the second layer, they are three in number. The second layer of the muscles, so they are the flexor digitorum longus, then flexor digitorum accessorius, and lumbricus. These are the muscles of the second layer of the sole of the foot. So same, the calcaneal bone with medialis has tentaculum tali, and this is the calcaneal tuberosity, this is the calcaneal tubercle, and here to the calcaneum laterally there is a cuboid bone, and medially there is a board-shaped navicular bone which articulates with the head of the talus, and navicular bone articulates with the three cuneiforms, medial, intermediate, and the lateral cuneiforms, and how the medial is with the first metatarsal, the second metatarsal, the third metatarsal, the fourth metatarsal, and the fifth metatarsal with the tuberosity laterally. And all these are having the phalanges, that is the proximal and the distal, and every finger has got three phalanges, the proximal, middle, and the distal. So first muscle is the flexor digitorum longus. So first word is telling that it will bring about the plantar flexion. Second word is digitorum, and third is the longus. So this muscle is actually the muscle of the posterior compartment of the leg. If you remember the structure passing behind the medial malleolus, first is the tibialis posterior tendon. Then second name is the flexor digitorum longus. Now this flexor digitorum longus, we have seen that it enters into the sole of the foot. Now we will see what is the fate of this. So this tendon, after touching the sustentaculum tali, now it enters the groove over the oblique groove or the lateral surface of the navicular bone. So this tendon flexor digitorum brevis longus will enter into the groove over the plantar surface of the navicular bone. And this groove is oblique, so the direction of the tendon of the flexor digitorum goes from medial to lateral side automatically. And this groove is converted into a tunnel by a ligament, which is called the spring ligament, which is the calcaneonavicular ligament, below which this tendon passes and it becomes oblique and runs laterally, and as its name is digitorum, so the tendon will be divided into 4 slips. So the one slip goes to the every finger. As it is longus, so it will be inserted on the base of the terminal phalanx of all the fingers. So one slip to the 5th digit inserted over here, another to the 4th, so in this way, this tendon of the flexor digitorum brevis got its insertion on the plantar surface of the bases of the terminal phalanges. The 4 slips, 4 tendons to every finger, every digit. So that is the fate of flexor digitorum longus. So what will be the action? So action of this muscle when it contracts, it will bring about the flexion of the finger. But the pull of these tendons on the finger is different. It is not equal because of the obliqueness of the tendon. The little finger will be most flexed and subsequently the first finger will be least flexed because of the unequal pull of this muscle, because of its obliquity. So in order to maintain the full flexion, plantar flexion of all the 4 fingers together, a muscle, new muscle has to be introduced. That is called the flexor digitorum accessorius. So flexor digitorum accessorius muscle is a accessory muscle. And this muscle will act along with the flexor digitorum longus muscle to equalize the pull of the longus muscle to each and every finger so that it should be fully plantar flexed. So it is a small muscle, it is a quadrilateral or quadrangular shaped muscle, flexor digitorum accessorius. So it is also sometimes called quadratus planti is the name, sometimes it is given. Quadratus planti may be the second name of the flexor digitorum accessorius muscle. So this muscle takes origin from the 2 slips, the medial and the lateral head. The medial slip, it takes origin from the sustentaculum tali, plantar surface. It is a muscular part and it runs forward anteriorly. While the lateral part of this muscle is aponeurotic and it takes origin from the plantar surface of the rough surface of the calcaneum between the tuberosity and the tubercle. This area is the origin of this lateral aponeurotic part of the flexor digitorum accessorius. Both the lateral and the medial part of the muscle is inserted over the lateral border of the tendon of the flexor digitorum brevis longus. So muscle is inserting over the muscle. The tendon is inserting over the tendon, that to be noted. So muscle is inserting on the muscle, tendon of the muscle and the tendon of the another muscle. So whenever the flexor digitorum longus muscle contracts, this flexor digitorum accessorius also contract. So both the muscles when contract together, now because of this muscle, the pull of all the 4 slips of the longus muscle will be equal. So this is the equalizer muscle. So that is okay. So origin, insertion. Now comes the lumbricals. The word lumbrical means worm-like, earthworm. They are cylindrical, earthworm-like small muscles which takes origin from the digitorum longus muscle, tendons. And these lumbrical muscles, like the worm-like, they go anteriorly. There are 4 lumbricals. The first lumbrical muscle takes origin from the tendon of the first finger, from the medial aspect, and is inserted over the medial part of the dorsal digital expansions on the dorsum of the finger. So it goes medially. It is unipinnate, while all the other muscles, lumbricals, we take them from the tendons of the longus muscle, they are bipinnate. The first, second, this is third. Bipinnate. And the fourth is also bipinnate. And they go and inserted on the fingers, in the root of the finger, and they go to the dorsal digital expansions on the medial side of all 4 fingers. So they go medially on the medial part of it. And where they go? On the dorsal aspect, and fuse with the dorsal digital expansion of the extensor digitorum longus muscles. And it is because of this action. So action of these lumbricals are, so they will bring about the dorsiflexion or the extension at the metatarsophalangeal joint. They bring about the extension at the metatarsophalangeal joint, but flexion at the interphalangeal joint. So that has to be remembered why the lumbricals are there. Now come their nerve supply. Now the first lumbrical is supplied by the medial plantar nerve, which is near to the lateral plantar nerve will supply the flexor digitorum accessorius muscle, and all the second, third and fourth lumbricals, they are also supplied by the lateral plantar nerve. Only first lumbrical is supplied by the medial because it is nearby. That you have to remember, the nerve supply of these lumbricals. So this is how we do the second layer muscles of the sole of the foot. Now come the third layer of the muscles of the sole of the foot. Same arrangement of the plantar surface of the bone. You have to remember the calcaneum anterior part, medially sustentaculum tali, posteriorly the tuberosity, the tubercle, laterally calcaneum articulate with the cuboid, with the oblique groove running over it, and medially is the board-shaped navicular bone with a oblique groove for it. Then all the 3 cuneiforms and the metatarsal bones, the phalanges of every finger. Second one, the third one, the fourth one is the cuboid, the fifth one is also with the cuboid, with the tuberosity at the base of the fifth metatarsal. And all fingers having the 3 phalanges. Here is the head of the talus, articulating with the navicular bone. So again, all the muscles of the third layer There are also three. You have to remember the names of the three muscles of the third layer. Name they are Flexor Halosis brevis, then Flexor digiti minimi, then Adductor Halosis. So these are the three muscles of the third layer of the sole of the foot. So we will take origin insertion. First we will take the Flexor Halosis brevis. Means it will do the plantar flexion. Halosis means it is made for the great toe, and brevis means the insertion will be the proximal phalanx. So regarding the origin of this Flexor Halosis, it takes origin from by two heads, a lateral and the medial head of the Flexor Halosis brevis. So the medial head of the Flexor Halosis will take origin from the cuneiform bones and adjoining part of the navicular bone and runs medially with the medial head of the Flexor Halosis brevis. The lateral head will take origin from the cuboid bone, and both the heads they mark toward the base of the proximal phalanx, and it bifurcates, the tendon bifurcates into two slips. One is inserted on the medial and one on the lateral aspect of the base of proximal phalanx. So this is the Flexor Halosis. So whenever this muscle will contract, what will happen? The thumb will move like this. So this is the plantar flexion. Plantar flexion is the action. Then Flexor digiti minimi. So this Flexor digiti minimi muscle will bring about the flexion of the little finger. So this muscle will take origin from the plantar surface of the shaft of the fifth metatarsal near the base and the shaft, and this muscle is also inserted over the lateral aspect of the base of the proximal phalanx of the little finger. Proximal phalanx of the little finger. So whenever this muscle will contract, so little finger will move like this. So this is the flexion of the little finger. Flexor digiti minimi is the name of this muscle. Now the third muscle left is the Adductor Halosis. So its name is Adductor Halosis. So it will bring about the adduction of the great toe. So this muscle has got two heads. One is called the transverse head, other is called the oblique head. The transverse head, as its name suggests, will take origin from the transverse metatarsal ligaments that we have done. This transverse metatarsal ligament. So its name is a transverse head, so it is a horizontal head. So it will take origin from the transverse metatarsal head of the third, fourth, third, and second degrees. And from here, this transverse head will go on the lateral aspect of the proximal phalanx of the great toe, and this slip will fuse with the lateral slip of the Flexor Halosis brevis muscle. This is the transverse head. The second is the oblique head of this Adductor Halosis, will take origin from the bases of the second, third, and the fourth metatarsal. From the bases by a semicircle origin from the bases of the second, third and the fourth metatarsal bases. And this muscle, as the name is oblique, so it runs obliquely upward and laterally, and the transverse and the oblique head, they fuse together. Transverse head and the oblique head, they fuse together and both form the combined tendon, which is inserted over the lateral aspect after fusing with the lateral slip of the Flexor Halosis brevis. So because of these tendons together, so a sesamoid bone develops here. Similarly, a sesamoid bone also develops on the medial aspect also. Because sesamoid bone develops in the tendon of the muscle. So almost 3 tendons, they are fusing on the lateral aspect of the proximal phalanx. So a sesamoid bone develops. And medially, another sesamoid bone also develops. So this is how we do the 3 muscles of the third layer of the. Now come their nerve supply. As we know, the medial plantar nerve supply the medial aspect of the muscles. The lateral plantar will go laterally. So lateral plantar nerve will supply the flexor digiti minimi. And it also supplies both the transverse and the oblique head of the Adductor Halosis. While the medial plantar nerve will supply the Flexor Halosis brevis. Whichever is near, it will supply. So this Adductor Halosis muscle, when both the bellies or both the parts they contract, so the proximal phalanx will move towards the first finger. And what is this movement? Adduction. So that's why this is Adductor Halosis is the name of this muscle. Now the last layer of the sole of the foot is the fourth layer. And muscles of the fourth layer, they are again 4 in number. The name of the muscles of the fourth layer, they are number 1, Tibialis Posterior, Peroneus Longus, and Interosseous. So Tibialis Posterior muscle of the posterior compartment, deep compartment of the posterior compartment of the leg we have seen. Now this muscle will enter into the fourth layer below the sustentaculum tali, and this muscle is inserted over all tarsal bones except talus. We have already done it. So when this muscle will enter, this tendon of the muscle tibialis posterior will enter into the sole. So it will divide into, it becomes aponeurotic and divide into various slips and goes to the first metatarsal, the cuneiforms, the third, second, fourth and fifth metatarsal bone. So this tendon becomes aponeurotic to all tarsal bone except talus. Because now here you see talus is not available. Because talus lies below the spring ligament. So talus bone is not available, that's why it is not inserted over the tarsal bone, that's why we say. So this is the fate of what is called the muscle of the tibialis posterior, inserted over all tarsal bones. Like this. The calcaneum also. Then secondly, the Peroneus Longus. We have already done in the lateral compartment. The Peroneus Longus is inserted over the base of the first metatarsal. Which surface? Lateral surface here. So this muscle is from the lateral compartment coming behind the lateral malleolus, and then a groove is waiting for this muscle, tendon of Peroneus Longus, over the cuboid bone. So this groove is already oblique. So this tendon of the Peroneus Longus will enter into the groove and it passes below the bases of the all the metatarsal and inserted over the lateral surface of the wing because it has to do the eversion. So that is the Peroneus Longus tendon lying in the fourth layer, last layer of the sole, touching the bones, inserting over here. And here sometimes the sesamoid bone develops. Then the last is the introtiae. So introtiae there are two. One is called the dorsal introtiae and plantar introtiae. So these introtiae, as the name suggests, they take origin from the adjacent side of the metatarsal bone. For them you have to remember two words. For dorsal you have to remember dab. For plantar you have to remember the word pad. So what is the meaning of dab and pad? D for dorsal introtiae and AB tells the action. So all dorsal introtiae, they are the abductors of the fingers. P for plantar introtiae and AD for means adduction. So plantar introtiae will do the adduction and dorsal introtiae will do the abduction. Second thing you have to remember, D for double. All dorsal introtiae, they take origin from the adjacent side of the metatarsal bone. So they are bipinnate, double, while the plantar, they are unipinnate. So double means dorsal introtiae, they are 4 in number, while the plantar, they are 3 in number. That you have to remember also. And another thing you have to remember about the introtiae, that all the introtiae, they are plantar and the dorsal, they are supplied by the deep branch of the lateral plantar nerve. Deep branch of lateral plantar nerve is this nerve supplied by the same nerve. So this is how we do the muscles of the layers of the foot, the last, the fifth metatarsal, the fourth, the third and the second. So the introtiae muscle, they take origin the plantar one. So plantar, they are unipinnate and they have to do the adduction. So if these fingers has to be adduct, so they will be like this. And introtiae will take origin from the, for example, from the third metacarpal and inserting over the base of proximal head. So when this muscle will contract, finger will move like this. So this is how you have to show the origin insertion of the plantar introtiae. Similarly, the second one will be here. The third will be here. Because there are 3. So 3 fingers, they have to be adduction. Why fourth is not present? Because we know fourth is related to the first finger. And we have taken the standard. Why we have taken the standard? But because the first finger has got no adduction and no abduction movement. That's why the fourth plantar introtiae is absent. So this is the reason. And on the dorsally, they are double. So they are bipinnate. And they have to bring the abduction. So they will be inserted over the lateral aspect of the proximal phalanx. So they are number 1, 2, 3 and 4 are there. They take origin from the adjacent sides. Because their interspaces are the 1, 2, 3 and 4. So they are bipinnate, the dorsal one. So one is inserted over the medial aspect. This is second dorsal introtiae. It is inserted over the lateral part. Then this is the third. It is inserted over the lateral part. And this is the fourth dorsal introtiae. It is inserted over the lateral aspect. So 1, 2, 3 and 4, they are the dorsal interosseous. So their name is DAP, means they have the abduction. See, the first finger is having the insertion of medially as well as laterally. So when both will act, the finger remains stationary. And the third will inserted over the lateral aspect, so it brings about the abduction of the middle finger. Then the fourth dorsal interosseous is inserted over the lateral aspect of the third finger. When it will enter, it brings out the abduction. And there is no abductor for the little finger because it is already having the abductor digiti minimi we have done in the first layer. So there is no interosseous for this. So this is how to understand. The common sense to remember the dorsal and ventral. And all are supplied by the deep branch of the plantar nerve. So all the concepts. Another thing we have to see is the dorsal plantar arterial arch. We have seen that there are two arteries are there on the medial aspect, the medial plantar artery, which is smaller. The lateral plantar artery is bigger. Remember, medial plantar artery is smaller, but medial plantar nerve is bigger because it has to supply 3.5 fingers. Lateral plantar artery is bigger, but lateral plantar nerve is small because it only supplies 1.5 finger. Opposite. So lateral plantar artery goes laterally, branches the posterior tibial. Along with the lateral plantar nerve, it reaches at the base of the fifth metatarsal near the tuberosity. From here, this artery turns medially and it pierces the oblique head of the Adductor Halosis. Oblique head, and supplies it also. Then it reaches near the gap between the base of the first and second metatarsal. While it is going from lateral to medial side, it becomes arc-like. So this is called the plantar arterial arc. And why it is going here to meet with the dorsalis pedis artery? Because we know dorsalis pedis artery is waiting for the lateral plantar artery, the cleft between the first and second metatarsal from the dorsal. So this is how the posterior tibial communicate with the anterior tibial. So this is the collateral circulation we have already explained. So this is how the plantar arterial arc is formed. And from this plantar arterial arc, various branches are given. The first digital branch given to the little finger is the first digital branch of the lateral plantar artery. Then metatarsal branches. So metatarsal branches are given by the dorsal plantar arc, and these metatarsal branches, they supply the digital branches, which supply the fingers. So it has got 4 metatarsal branches. The first metatarsal branch is given directly from the lateral plantar artery. Another 4 is given by the dorsal arterial arc. Then the dorsal arterial arc near this basis of the metatarsal, it also gives the perforating branches, 4 perforating branches. These perforating branches from the plantar side, they go on the dorsum of the foot, and here they communicate with the arcuate artery of the dorsalis pedis. So there is a good anastomosis between the posterior tibial or lateral plantar artery and the dorsalis pedis artery, because these arteries, they will supply the plantar and the dorsal interosseous. So this is how we do the sole of the foot with the 4 layers. That's all.